Hello there, guys. Yeah, I'm starting it right now. I was having a little bit of an issue with the stream key. Apparently, I wasn't having the right one. So, hoping here is going to start now. I'm going to try to keep an eye on the chat. So, oh God, I hear my volume over here. Hear myself over here too. I was going to give it a little bit more time for, maybe a couple more people to show up. Hopefully, at least a couple will. I know there was 4 a little while ago, but now there was only, I would say, myself and one other one. So, hello, David. I'm not sure if Patrick is still here with us. Oh yeah, looks like you are. All right. If you guys have any questions, let me know. You can put them there in the chat. I'm gonna try to keep it looking at it every so often so that we can answer those questions. Now would be the best time rather than in the text or something. I hope I can explain it correctly. I know there's like, I don't even know how many 7 to 10 seconds delay between when, I'm saying something and you guys hear it. So that I'm hoping that you guys will be able to be up to date with whatever it is I'm showing here. I did get them to work. The MAX7219, you call them 7192, is the 7219. I did get them to work. It was only a very long time ago that I actually had a problem with getting it to work, and I gave up on it for a long time. But like I always said, in a lot of my videos, a lot of the times when we have issues, it's 99% of the time is going to be our wiring. But then I tried it again later on and it worked, no problem. And I actually have one of them in the panel right now that you're going to get to see that it's working. They are a little bit different how to connect those, but they're pretty much the same thing. So I don't know how many of you guys know already from my videos. Probably if you're here, it's probably because you already seen a lot of my videos or at least some of them. And for a while there, I gave up on making any more videos because it seems like every time I would make one, I would get a comment from the creators of SimVim, which looks like they didn't like the idea of creating videos because they say that it's confusing people. A lot of the comments that I've seen seem to suggest that a lot of people are benefiting from them. And I really only make videos of the things that I am comfortable with, the things that I got to work. Something that I've never played around with, like stepper motors or even LCD displays, I'm not going to talk about because I haven't done them and I haven't tried them. So I wouldn't even know what to suggest as far as, advice. But the things that I show you guys, I mean, you can obviously see that they're working, so it might not be the perfect way to do it, but apparently they're working for me. So that's what I'm trying to teach, and trying to get people that have less electronics knowledge and understanding about these things. I'm just trying to help, with those people. So, all right. So obviously, you know that we have to basically, let me go to the SimVim website here because this is where it all starts, correct? So everything, all the information for this project is at simvim.com. That's where you can find all the information about all the wiring and everything. You can do you can join the community, which I think it's a very helpful thing. You can get a lot of answers to a lot of questions that you might have or that other people had. You do need to apply, so they can accept you, but I think usually it doesn't take them too long to approve you. So I'm going to go ahead and remove my face from here, from the picture, just because I'm going to be looking all over the place. I'm going to be moving around, and I know this microphone is not the best quality, but it's a Bluetooth headset, so I can move around and walk around, which I'm going to need to do. And that's why I'm going to use this one. So having said that, let me remove my ugly face from here and we can get started. All right, so if you go to the SimVim website, the first thing obviously is the wiring. And for this particular thing, you need to have the data bus, because the data bus is going to be what gives you the ability to basically have a ton of connections, like a bunch of screens, LCD screens or 7-segment displays, or a lot of switches, a lot of encoders, a lot of anything. So that's why the data bus is very, very important. And these, as many of you might already know, are using pins number 22, 23, 24, 25, 26, 27, 28, and 29. So that's what the names of the four data lines are. And then this is the T, the D, and the L line, and then the signal line. I'm not sure exactly what these mean, the TDL. I don't see any explanation anywhere about what they mean, but you must have them in the correct order so that when you connect anything to them, you are connecting them to the right one. And I'm thinking that the last time I had a problem with the 7219 7-segment display, that's probably what happened. I didn't have my wiring correctly done, and that's why I was having issues. But so my data bus, this is what I use for my data bus. And as you can see, I have an 8-wire uh, conductor here that has enough for all 8 of them. So obviously, I'm gonna have them from 22 to 29. And because you can only have, one connection here, I use this little made up little thing here so that I can multiply it. So I bring my 8 data bus and signal lines and everything wires over here, and then from here I can connect more and more and more to multiply them. And that's the reason I have a little jumper here in the middle, because if you look on the bottom of this little brown board, there is no continuity between here and here, between the middle pins. So I have to jumper them so they can continue having conductivity to the other side. And of course, each one of them is a separate line. So um, so basically, he recommends that you have a resistor between each line and the Arduino. But he says that if you can make sure that your wiring is very solid, like it's not very loose, or you're not going to have jittery stuff, you can not use them. They're kind of like optional. So as you can see in my picture, I don't have any. I have just the wires directly, and I'm hoping that all my wiring is good. Oh, thank you, man, for Alan, for saying that I'm an inspiration. I'm a beginner, like everybody else, and I'm just trying to do my best to help out here. Hey, Dave, I haven't seen you in a long time. AliExpress, oh, cool. I thought you had already started your cockpit before, a long time ago. But yeah, the funny thing about these things is like once you get started, it's like a never-ending project, huh? So going back to this, um, so once again, you basically are going to have your data bus. I call it a distribution hub. And as you can see up here, I'm going to talk more about this right now. But as you can see up here, I'm using the orange, white, yellow, and green. That's for an input multiplexer that's connected in my test panel. And over here, you can see I'm using one more wire, the blue one. So that this is for an output multiplexer. And you'll see right now as I'm, going through the rest of this, how that all works out, how it's all connected. So once again, talking about the resistors, they're recommended, but they're optional. So far, I have had a little bit of problems with my setup, but it's not like something really, really bad that I can say, that it's not working. The little bit of problems that I have had have been because of little bad connections here, but it hasn't affected it to the point where it's unusable. So all right. Yeah, you're like me, Dave. Once you get started and you keep adding stuff, you never stop. So, and it's always good because there's that flexibility, of being able to keep on going. So, obviously, for the connection of, different things, you can connect them directly to the Arduino. So, once again, over here, he's mentioning the data lines and everything. But if you wanted to connect things directly to any pin, you can obviously just, connect them directly to the pin. So an encoder, you would put the middle pin to ground and the other two, which are left and right, you would connect to 2 consecutive pins. And I've talked about this in my other videos that the 2 legs of the encoder, they have to be on consecutive pins. You cannot have like 30 and 32, or 34 and 39. They have to be consecutive. The three position toggle switch, same thing. You're going to have each leg of the toggle switch to a pin, and you're going to have the middle one to ground. A multi-position switch, same thing. Everything goes to ground except for all the individual contacts of the switch. And single toggle switches, obviously, they only use one pin because it's only one pole. And momentary contact buttons, also just one pin each. So this is what you would do if you wanted to connect everything directly to the Arduino. But as you'll quickly find out, and I sure did, you run out of spots, out of pins in order to be able to connect stuff. And you can only use one at a time, one 2560 Arduino. You cannot use many of them. So in order to do that, you're basically going to use multipliers in order to get a ton more inputs and outputs. Let me answer a few questions here, and then I will continue. All right. Can I please talk a bit more about SimVim complaining and comments to your videos? What was confusing? So basically, what a lot of the things have changed over the years. Let me put my webcam back for a little bit. So over the months and years, since we started using this project and he started building it, um, they've been changing a little bit of how you connect things, how you configure things in the configurator, which we're going to go into in a little bit. So there's a lot of things that have been changing, and a lot of the earlier videos that I made, some of them I took down, a couple of them that he asked me if I can take them down, and some of them I only put comments on there on the description that things have changed a little bit since I recorded that video, because he was telling me that people were writing to him and complaining that they're following the instructions in my videos, but they can't get it to work. And that's because the things changed. And obviously, if you see something in one of my videos and you go to the website and it doesn't look the same anymore, then obviously it changed already, and whatever I did show in my videos is not going to work the same way. But regardless of that, so I said, okay, I'll take those videos down. I took two of them down only, and it kind of upset me because when I record one of these videos, this is the first time ever that I'm doing something live. But when I record, actually the second time, the other little teaser that I put up the other day was the first time. When I record one of those videos, some of them, like one of the ones for uh, custom data reps, I think it took me over 6 hours to make that video, and when it was like, you need to, can you please take it down because you're confusing people, I was like really, really disappointed. And you guys noticed that for a very long time I didn't record any more videos. So, but people kept asking questions and everything, and when I feel like, yeah, you know what, I can answer that question, then I'll go ahead and continue doing it, I guess. This video right here that I'm doing is specifically because somebody asked me if I can show them how to wire multiple 7-segment displays, to a multiplexer. So that's what I'm doing here. This is the whole thing. Now the question about working with MSFS 2020, no, this will not work right now with MSFS 2020. Um, from what Vlad said, is that in the future he wants to make it work with all the simulators, probably with P3D, FSX, and 2020, as well as X-Plane. But in order for it to do that, I would say there has to be an API that he can make the plugin communicate with the simulator. If he can't get it to communicate with the simulator, then it won't work. And I'm assuming that if other products like SPAT Next, which is what I'm using right now to use my SATEC panels with MSFS 2020, if they can do it, if they can communicate with the simulator, I would assume that something similar could be done with SimVim Cockpit. So I hope it does. Um, all right. Oh, they're working on it for the simulator. That's cool. So, all right then. Oh, it was you that asked me about the 7-segment displays. Okay, well, good. I'm glad you're here. All right, so we're gonna go back to the wiring here. So in order to do multiple, uh, a lot more connections, um, so we're gonna use multiplexer boards or MUX boards. These are 16 channels, so you can connect 16 inputs or outputs to each one. And each one of these only uses one pin on the Arduino. So it makes it, very expandable because I think you can connect up to like maybe 500 or 600 buttons and switches and stuff. So obviously that's very good. All right. So in the multiplexer world here, remember I was talking about the data bus. So this is for an input. So, this is obviously right here is going to be a little bit different for the inputs than it is for the outputs, but it's just going to be oh, you already kept going. That's cool. You built the MCP panel even before I got a chance to answer you. That's very good. So, you're going to basically, these are going to be all your inputs for encoders, buttons, switches, whatever, push buttons or whatever you want to use. And then this is the one pin that's going to go into the Arduino, the Z, which is the signal. And then you're going to have your data lines, S0 through S3, and then your 5 volts and your ground. Now, if you notice that the EN pin also goes to ground. So what I've done with mine is in the back of it, I wire a little jumper from here to here. That way I don't have to connect two different wires to ground. It'll just be jumpered from EN to ground, and then this one will be connected to the ground. Um, so do you buy the multiplexers with the pin connectors already soldered? If not, how on earth can you solder such a small board? No, I don't. I actually don't. I buy them without any pins or headers or anything, and then I solder them. And you just have to have a very, very tiny tip soldering iron. It's not that hard. When you heat up only one pad, the solder will usually just flow to that one without making a big mess. So it's not that hard once you do it a little bit. All right, so for the outputs, this is if you're going to use 7-segment displays, which is what we're talking about mostly on this video here. This one right here, it's a little bit different because if you notice, you have the data lines are still in the same location, but now where the pin that would go to the Arduino, now you're getting the signal data line, which is I think was pin number 29. So that one is coming out from the either directly from the Arduino or from the data bus hub, like the one I created. And now the EN is the one that's going to go to the controller, to the Arduino. So remember on the other one, the EN was also connected to ground. On this one, it's not. This is the one that goes to the Arduino. And this one, of course, ground and 5 volts. All right, so the reason why we use multiplexers is because you don't want to do this. This is what my little test panel that we're going to be working with today, this is what it looks like. It's a freaking mess. And the reason, I leave it like this because it's only a test panel, so it's not like a final product. So I leave the wires long so that I can change things around and everything and do whatever I need to do without, having such a small space where all the wires are tied together and then I can't change anything. So that's the reason why it's this. But if you were to not use multiplexers or if you were not to do very, much neater wiring, obviously this is what you would end up with and it's like very confusing. So, okay, hold on. I think I got another question here. Um, the connection wires, well, that's exactly kind of what I'm answering right now is like you don't want to do this because obviously the messier, the more wires you have, the more of a mess it is. So you need to try to keep them as short as you can, but at the same time, you need to be able to maneuver them around everything else that you need to, and if you ever needed to change out components, it would be nice if you would be able to just get to a certain component, get it out of there and then replace the wires. So I'm going to show you a picture right now of something that I did, which is a pretty good example of how you should do it. But I would say if you can keep the wires to less than, 4 to 6 inches, that would be the best. I don't know exactly how much that is in centimeters, but um, what part are you not clear about in SimVim? The signal wires? Okay. Okay, I'm going to show you more right here because this right here is going to kind of show, what we're talking about the signal wires. a little bit more. So I'm gonna just basically use this opportunity to go over that again. So if you notice, this is the data bus, the data wires, which is S0 through S3, and then the D, T, DTL, and signal line. So that's what these are. And that's why I took it over to this little distribution board so that every time I connect another multiplexer board, either an output multiplexer or an input multiplexer, I just grab those same wires, I grab them from here and take them over to the multiplexer. And the same thing for an output one. But we're going to basically keep talking more about this right now. So hopefully by the time this is all done, you'll understand, what this all means. Okay, so this right here is another example of another part of a panel that I built. And you can see that I have two multiplexers right here. They're the same thing, they're just different colors, different manufacturers, I guess. But as you can see, I try to keep all the wires pretty neat here. So I have the double rotary encoders right here in the bottom, and they're all going to the multiplexer boards. And I have some buttons up here and more buttons down here, and they're also going to the multiplexers. So now the only thing I need to do is send, the data wires to the Arduino. And this is another thing that I could have, I did differently. If you notice, you see how I put both of them together here? So I have the two orange ones together here, the two white ones together, the two green ones together, and the two yellow ones together. So that way I only had to take one of each color that's coming from the data lines here to the Arduino, or to the distribution hub. There was no need for me to take all of these wires when they carry the same signals. So I just combined them, and then I just took one of each one to the Arduino. And then of course, you can't see it right here because I didn't have it yet, but in the signal pin right here at the end of each one, that's the one that was going to go to the Arduino. Um, I'm using, for these, I'm using 20 gauge wires is what I've found that works pretty good to put it into the holes of the little female little headers. Um, this one right here I think is a little bit bigger, but all the rest of them are 20 gauge. 22 gauge is the most common. That's the one that you can find everywhere. But all right, so now hopefully this will help you guys understand it again a little bit. Um, So this is two input multiplexers. So as you can see, there's only one set of wires. Let's say this was going to go to the Arduino, or I'm sorry, this is going to go to the data hub, like the one I built. Okay, so you can combine the four signal wires from one multiplexer with the other multiplexer. And like I was saying from the previous picture, you only need to take four wires to the distribution hub. And then the 5 volts and the ground, of course, you can also combine, so and you'll see the way I did it in a little while, all the pictures. Um, so this is going to be exactly like when you wired all the components directly to the Arduino, but now instead of directly to the Arduino and using up all the pins on the Arduino, you're going to basically go to the input on the multiplexer here. So each one that you would have normally hooked up to an Arduino pin, now you're going to hook it up to here. So as you can see, just using two Arduino pins right here, you can have 32 different things connected to it, which is pretty good. And a lot of you guys might already know all of this because you've already built, probably even better panels than me. But I think, just to clear it up for everybody who might not understand that, that's the advantage of using multiplexers, is that you can have so many more connections, rather than just whatever amount of pins the Arduino has. Um, all right, so this is another panel that I built, which I originally built it for the Challenger 300, but I ended up not even using it for the Challenger 300. I ended up just repurposing it. But right here, you can see that I kept all my wires pretty close together, as small as I can have them. And if you notice, all the ground wires are together. So basically I got this ground wire going to here, to here, to here, and then this one goes to the ground pin here, which is jumpered to the ground pin here. So all these grounds are just coming in through one wire right here, and then this one is going to the main ground of the entire system. And then the 5 volts, coming in right here. Um, and then the 4 data bus lines, S0, S1, S2, S3, and this is where the signal wire would go to the pin on the Arduino. So I got all these connections right here, and I'm just going to use one pin on the Arduino. And as you can see, I still have 2 available pins right here. So if I ever wanted to add a couple more things here, I can add 2 more things right here. But this is a good example of how the wiring should be done, not the way I did it on my test panel. So, and this is how it looks on the this is an input multiplexer, obviously, right here. So I got all my buttons and switches and coders and everything connected right here. And I'm using the 4 data bus wires. And the red one is going to the pin on the Arduino, which in this case is number 36. And then, of course, the ground and the positive 5 volts. And this one doesn't have anything because, like I told you before, I have a jumper wire going from the ground one to this one on the bottom side. So that's the input ones. And then the output ones is different because you have your ground and you have your 5 volts, but on the EN, that's the one you have going to the Arduino, which in this case is number 48 on mine. And then you have the 4 data bus lines, which it says 0 is 1, 2, and 3. And then you have the Z, which is coming from the signal. I called it an S over here because that's the way he has it labeled. So that one is going to the data hub as well. Now, if you were not going to make yourself a data hub like mine, and you were only going to use one input or output multiplexer, all of these 5 wires, the orange, white, yellow, green, and blue, would go directly to this area here where the data wires are. But that wouldn't be very practical because you're probably going to need more than one. So yeah, these are solid core. All the wires that I use are solid because I find it easier to insert them. If I didn't use solid core, I would need to put terminators on them, the sharp terminators. And I have done that before, for some of them. You probably see them in some of my other pictures, but um, yeah, I would actually recommend, if you can do it, use very thin wire because it's a lot easier to work with. Because when it's pretty thick, it becomes like there's just too much. So if you can use like maybe 22 gauge or 24 and you can learn to work with that, that would be even better. This doesn't carry a lot of voltage, so you don't really need thick wires. You can use a lot thinner than what I'm using here. All right, now we're going to get to the fun part, um, wiring the displays. So this is where a lot of people apparently are having issues because it is a little bit different. So once again, we're going to talk about the signal lines, the D and the L, and then the 4 data bus lines, and then we're going to talk about ground and 5 volts. So kind of what he's trying to show right here, and all these pictures are on the SimVim website. So what he's trying to show right here is that you're going to get the 5 volts is going to be common. So you can connect the same 5 volts that you're getting from either a different power supply or the Arduino itself, and you can connect it all together, and it can go to every single 7-segment display that you have. And it can also go to the DM13A LED drivers, which I also have a video about that I already done. So the 5 volts in the ground is pretty self-explanatory. Um, and you can see that it's just this one goes to ground, this one goes to voltage. That's it. The D in, which I think is probably digital signal in, I guess, that one is going to go to the D line on the data wires. Remember, there's a D, an L, a T, and an S, which is a signal right here. So that would be, going to the CS pin on the 7219. And if you wanted to connect something else to it, you can see that you can share the lines because they're all going to end up on the same data line. So you can share the lines. This one connecting to the same line here and then going to the main hub. And then this one is also connecting with this one here and going to the main hub. So you don't need to carry individual wires for each one of these. You can share them. You can combine them. The only one that you cannot combine is the clock signal because that one has to send the data individually to each display. So if you notice here, every single clock wire is going to a different pin on the output multiplexer here. And the pin that's going to the Arduino is the Z line, which is using the signal line, which I called S on my picture over here. That's the one I called S. So that's the blue one. That's why right here you're using 5 wires because it's the 4 data lines plus the signal one. That's the blue one on mine. All right. And of course, with on this one here, you need to have a resistor on the clock line, and also for the TM1637, which is the ones I'm going to be talking about more here. And the 1637, as you can see, is a little simpler because all it uses is the positive, the negative, the digital input line from the T, and the clock signal, which goes to the pin either directly on the Arduino or on a multiplexer if you're using output multiplexers. And this one has to be also grounded with a resistor, 1 to 3 kilo ohms. I'm going to be honest with you, I don't have a resistor on none of these right now that I'm going to show you, and they're working fine. The only reason he said that you should use a resistor is because if you have a lot of displays, you might get interference. You know, there might be a little bit of weird numbers and everything showing up. So this is kind of like to isolate them and make sure the signals that they are receiving are pure and clear. Okay, so it is highly recommended, probably even required that you use one, but I've just been lucky and I haven't had any problems with mine. All right. Well, we already talked about this one. This is if you were going to go directly to the Arduino instead of a multiplexer. This one, you would have the 5 volts, the ground, the D and the L data lines, and you just got to know which one you're going to put it into. And the clock signal, instead of going to the multiplexer, is going to go directly to the Arduino now. And I believe I have one of mine directly to the Arduino. So this is a little diagram I made a long time ago when I was trying to explain to somebody how to do this. um, it's not very neat, but anyways, I don't know, maybe it was for you, David, that I did it. I'm not sure, but I put it in one of my videos. I put it as a link. It's in my Google Drive. So we're gonna see it all in actual wiring right now on my messy test panel, but one more time we're gonna go over it just so hopefully it'll clear it up. So once again, we're going to pretend that this is my distribution hub right here in the middle. And you got the pins 22 to 29. You have the S0 to S3, the D, T, L, and S lines. And you're going to bring them over to your distribution hub. Okay? Now, you can either get the 5 volts directly from the Arduino here, or you can get them from a separate power supply. But I'm going to show you how I did it right now when we switch over to the camera. And you got the ground, which you can also get directly out of the Arduino. All right. So that ground and that 5 volts is going to be shared between every single display. You're just going to basically split off of it, and go to every one of them for the ground and the 5 volts. And the same thing for the T line, which is the DIO, digital input output, I guess. So you're going to get the T line directly from the distribution hub, and you're going to take it and split it off, and you're going to go to all 3 displays. The only one that needs to be individual, like I told you before, is the clock signal. That one has to go individually to pins on the multiplexer, or it needs to go directly to pins on the Arduino if you're not going to use a multiplexer. Now, once again, for the pins on the multiplexer, you have the ground, the voltage, the EN goes directly to a pin on the Arduino, which in my case is Arduino pin number 48. And then the 4 data lines, S0 through S3, go to my distribution hub. And then Z is the signal line that goes to the signal line from the distribution hub of the data bus. So this is pretty much the basics. And then the voltage and the ground for this, once again, you can get it from the same voltage and ground you get over here. The voltage, unless you're going to have a lot of displays, you can get the voltage from the Arduino because they pull very little power. But if you're going to have a lot of them, and I don't know exactly the number because you have to kind of do the math on how many milliamps each one requires, you will need a separate power supply, and it is recommended. Any questions up to now? The Max is the hardest one for me. I actually don't have it set up for the Max right now. I have it set up for the TM1637 because those are the ones that I used. But I will try to explain to you the one for the Max that I also have right there. Okay, as a Max, yeah. Basically the 5-volt power supply, you can use the same power supply that you use to supply the Arduino because I don't think anybody recommends getting only the 5 volts to the Arduino from the USB. So I've been using it's about 6.6 volts. I believe you can use anywhere from 5 volts to 9 volts is what's recommended. But I'm using the power supply that I have, it's about 6.6, even though it says it's 5. All right, so you want me to do this like if it was a MAX7219? So let me see if we can do something here. Improvise on the fly here. All right. Oh, that's just great. All right, so you're gonna have the 5 volts, and you're gonna go to the 5-volt line here, and then you're gonna go to you're gonna get the ground, and you're gonna go directly to the ground. It doesn't give me no more colors, huh? Yeah, it does. So we're gonna take the clock, and we're gonna take the clock and go directly to one of the pins on the multiplexer here, and then that didn't work. Okay. Well, since it doesn't want to give me any more colors, we're gonna take the D line, and we're gonna go directly to the D line over here, and then that's it. And then we're gonna take, I'm just gonna use blue again, okay? I'm gonna take the L line, and we're gonna go directly to the L line over here. Oops. Is the L, okay? So this is the L, this is the D, this is gonna be the clock signal going to the display, and then the positive and the negative. And that's it. Don't forget, you gotta have the resistor right here somewhere between anywhere, as long as this line has a resistor going to ground. Basically, you're gonna have a resistor right there. And that's pretty much it. Did that make it any clearer? All right, we're gonna switch over to my camcorder over there on the other side. And we're gonna look at how my wiring is done, which, like I said, is very messy, but I don't want you to use that as an example of how to do it. I just want to try to see if I can explain all these things. All right, so I'm gonna zoom in a little bit right here. All right, oops. So for this panel, I have the 3 1637 displays, and I have 3 encoders, 1, 2, and then 3, one on the bottom. I have a toggle switch right here, and I have 2 push buttons, one right here and one way over here on the other side, which you can't really see from here. So first things first, all the positive wires from all the displays and all the encoders, I put them all together, and they all join up right here. You can probably see that I have a bundle of wires right there. So that all goes to a power distribution little thing that I have over here. So it's getting the 5 volts from this rail right here. So all that line is giving the 5 volts to everything that uses 5 volts. But as you can see, I only used one little red line over here to give the 5 volts to everything. The only thing that has to be separate for this in this circumstance is the signal wires from the switches, the two toggle switches right here, and the two push button switches and the toggle switch up here. Those have to be separate because those are not 5 volts. Those are going back to the multiplexer. So if you can see right here, these are the 3 red ones that are coming from those 2 buttons and the toggle switch. So those do not join up with the 5 volts that is going to all the displays and all the encoders. Okay? So the same thing for the ground. If you notice on the ground, in the ground, everything, all of them, all these brown ones coming from the displays, the encoders, and the buttons, and the toggle switch are all together. So they're all right there. So I just put plastic electrical tape, I guess you can say the brushing that you just brush it on. So all the grounds are together, and I'm just taking one ground, which is that, oops, sorry, which is that brown one right here, and I'm taking it to the pin on the Arduino. And as you can see, I also combined the grounds coming right here from the output multiplexer and the input multiplexer. I also combined it with that one. And that one is going to my Arduino. I don't know if you could see it over there, but it goes into the Arduino over here. So one ground wire to combine all of them, okay? Now let me go look at the comments real quick to see if anything has been asked. Yeah, it's pretty confusing when you haven't done this kind of stuff. It's pretty confusing, Patrick. But you know, I've just learned as I go along. You know, sometimes it's a little bit of I guess you can say trial and error. But for the most part, you know, it's been okay. It's been working out pretty good for me. All right, so now we got the positive and we got the ground. The next thing, remember for the TM1637, if you remember, you have the T line, right? The T line is going to go directly to the data hub. So the I believe I used the gray one. Yeah, I used the gray one. So the gray one right here, you can see I'm getting one gray one for this display, another gray one for that display, and somewhere way down there I have another gray one for the third one. And then I combine them all right there. Oops, so every time I zoom in a little too much. I combine the 3 of them right there. And that one gray line goes over to my, if I can find it, right there. So that one gray one goes in right there into the T line of my distribution hub. So 3 gray lines combined into one, and they go into the data distribution hub right there on the T line. Now the only thing that is different right here, that like I said, it has to be completely separate, is the clock line. And those are the yellow wires right here. So I got one for this display, this one over here for that display, and then another one at the bottom that you can't really see, but it's coming out way over here on the bottom. And those 3 are going to my output multiplexer right there. So the only thing I have on the output multiplexer right now are the 3 clock wires coming from each one of those displays. And then I have the positive, the negative. I have the 4 S0 through S3. And then I have the EN wire going directly to the Arduino, which in this case is, if you follow it way over there, I believe I have this one on pin number 16 on the Arduino. So pin number 16 on the Arduino goes to the EN, and then you got S0 through S3 plus the signal line, which is the blue one on mine, going right here to my distribution hub right there. So these wires are all coming over here and they're connecting right there. Okay. Now, let's talk about the rest of these. I'm sorry about the zooming here. It's not perfect, but all right. So that's it for the outputs. Everything else, I got the rotary encoders that I have right here. This is one of them here, and this is another one right here, and that's another one down there. So all these green wires are coming from the encoders, and they're going to the input multiplexer right here. So all the green wires are from the encoders. The red wires are from the push buttons and from the toggle switch. And then I got two black ones, which you can barely see right here. No, actually it's three black ones that are coming from the center pin on each one of the encoders. So all in all, I'm using 12 pins. Oops, you can't really see it right there. So I'm using 12 pins on the multiplexer one, the multiplexer input board right here. So the green ones are for the encoders, the red ones are the push button and the toggle switch, and the two black ones or three black ones are the push buttons on the encoder. Let me see, I have a MAX7219 way over there. You can see it right there. Oops. So that one right there, I actually have it. You have the red one is the 5 volts, the white one is the ground. I believe the middle, the yellow one is the D line, is going to my data hub right here. The green one is the L line, and the white one on the bottom, that's the clock signal. And you can see right there, because of the way I did it a long time ago. Oops. Let me see if I can focus it. Come on, buddy. Okay, that's pretty clear. So you can see that I put a resistor right there. And I didn't do it the right way because I didn't have anything that I can think of real quick. I just did it separately. So that blue wire that's right there is actually going to ground. And I just did it separately. So that one is with a resistor that's from the clock signal is going to the ground. And the actual wire, that one that I think I told you that it was going directly to the Arduino. It wasn't going to my multiplexer, or I'm sorry, my output multiplexer. If you look at which one is it? No, actually that one is going to a multiplexer. Never mind. It's actually going to that output multiplexer right there. Is that green wire right there? Is the one going to that MAX7219's clock signal. All right. So hopefully you guys are understanding everything up until now. What I'm going to do now is I'm going to show you guys how to program all of these, just in case you guys haven't. The resistor on the 7-segment display, yes, you do need a resistor on every single MAX7219 on the clock line going to ground. So yes, the answer is yes. All right, so let me see what's next here. And all of this that I'm trying to teach everybody, that I'm trying to help out with, I just learned it as I go along. I didn't know a lot of this stuff. I had never ever worked with Arduinos before I did this, so it was new to me. I'm trying to delete some stuff that I had put up, just so that I can start fresh and show you guys how to do the whole programming thing as well. The outputs of the Max. Oh, I think that's because on that particular Max, maybe it was labeled differently. That's probably why. Because I think that's what it was. It was the letters on the back of my Macs were different than they are in what SimVim shows. And I think that's why I was having those issues, because I wasn't sure exactly how to connect them. You cannot connect two Arduinos on one sim. You can only connect one. And if you go back and watch the beginning of this video or many other videos that I made already, you can see why you don't need more than one Arduino. You can't, at least not with SimVim Cockpit. With SimVim Cockpit, you only need one, and you can have up to 500 or 600 different buttons and button switches and all kinds of stuff. So the answer to your question is you do not need two Arduinos, and you cannot use two Arduinos. What's up, Sim Aviator? You finally made it, huh? All right, so let me show you. I'm gonna see if I can show you that MAX7219 and see if I can see what you're talking about, because now you got me curious about that. Oh yeah, you're right. It does say LODA and some other stuff right there. So yeah, so basically I just had to learn that Max 7219 had different letters than what I was expecting from, the website, and I just had to basically figure out which one was which. And I will look at that and I will let you know, maybe in the comments of this video, I'll let you know exactly what that was. But for the meantime, let me, like I said before, let me move the camcorder so that we can then go to the rest of this video from the front of this display panel. All right, so let me see how this camera angle looks right here. I think it'll have to do right there. Doesn't look like it's very sharp, but I think it's legible enough. All right, so now we're gonna have to program this, all these things. So basically, I already have everything. Well, it's programmed right now because I just erased part of it, but I had set up this one right here is set up to the vertical speed. It was actually. This one right here was set up for the transponder code. I had this light. This is what I'm going to set it back up to right now, but I'm just going to walk you guys through the whole thing. This one right here was set up when I engage the autopilot. This would be the command A light on. And this one I had set it up for when you disconnect the autopilot. This will be the warning light. And then this is a brightness knob that I had assigned. We're not going to worry too much about this because we're worried more about this side right now. This is what this video is all about. So I'm going to show you guys a couple of things here. I'm going to show you guys how to assign two different displays to the two different functions to the same display, and we're going to use this encoder to switch those two functions. So I'm going to use the course 1 indicator and the course 2 indicator for this one. For this one, I'm going to use the heading. I'm just going to use it as a heading indicator, and then switching it with the encoder here. This toggle switch, I'm going to use it for arming the auto throttle, and this light hopefully will turn on when the auto throttle is engaged. This one right here is going to be for altitude and for vertical speed, because vertical speed needs more than 4. This one only has 4 segments. You need at least 5, I believe, for vertical speed. So this one we're going to use 2 functions on it. And then this button I'm going to use to engage the autopilot, command A, and this one I'm going to use to silence the alarm when you disengage the autopilot. And remember, each one of these encoders has a push button on them. So this push button is going to allow me to switch this between course 1 and course 2, and this one is going to allow me to switch between vertical speed and altitude. All right. So any questions up to now? Oh, one day you'll have a studio? Yeah, yeah. You're already almost there right now. I mean, you've been doing a lot of work with that lately. By the way, how is the video looking right now, considering that it wasn't very good the other day? I tried to make sure the lighting was a lot better this time, but Obviously, my webcam, I think you could that one you could see that it is clear. It's I don't know why for some reason the webcam has a better picture than my actual camera, the camcorder, which is behind me down there. All right. Yeah, I probably should have asked a long time ago, huh, about that. So we're gonna go here to the simulator. Thanks, guys. I'm glad it looks good this time. Last thing I would want is a video with terrible quality or terrible audio. So we're gonna go to the configurator now, and I'm gonna show you guys what my little list looks like right now. So right now, my configuration file looks like this. I do have a couple of things assigned to the left part of the test panel that like I told you, we're not dealing with that right now. And these are the lights, some of the lights that I have on those little LEDs that you see in front of the test panel, but we're not going to be concerned about those right now too much. So we're going to go ahead and go to the configurator, and we're going to start assigning all these things. So you can see right here that I do have, a couple of things like the transponder code is on that 1637. And then on the other multiplexer, I do have a couple of functions assigned to it. But this is all on the left side of the test panel. And right now, we're going to basically configure the right side of the test panel. So first things we need to do is we need to remember where we have attached the output multiplexer in the input multiplexer. So since I don't remember that, let me take a quick look. Okay, so the output multiplexer is on pin number 14. So yeah, maybe I should remove that camera for now. So basically, if we go to pin number 14, we have to assign a multiplexer for 7-segment displays. So that's what we're going to do here. Is that El Pigo? Oh man, check it out. Even Pigo came here. All right, so we need to tell it, I have a 7-segment display on number 5, on number 10, and on number 15. That's where I put them. So I have to tell it that on pin number 5, I want to connect a 7-segment display, and it's a I'm sorry, it's a 1637 4-digit module on this one. And we're going to put it confirm. And then we're going to do the same thing for number 10. 7-segment display, 1637 4-digit module, and then confirm. And on number 15, we have a 6-digit mod. Is it 6? Yeah, it's a 6-digit module. So number 15, 7-segment display, 1637, but we're gonna leave it on 6-digit module. Now, I talked about this in my other video. If you were gonna connect one of those DM13As for LED lights, which I do have one connected here, and I did talk about it on another video, you can select it here as well. If you had a MAX7219, you can also select it here. But like I said, right now we're only dealing with 1637s right here. So confirm. So now we have our 3 displays set up right there, right? All right, so now that we have the displays, we have to tell it what we want to assign to them. So what we're going to do is we're going to assign, I think I had told you guys, we're going to assign, let me see, we're going to work with the MCP panel mostly. So let me just, I'll put it right there so that when we're looking at it, we can be looking at both things at the same time. So we're going to assign for the very left one, we're going to assign the course 1 and the course 2 heading. Okay. Man, this is going to be a long video. So we go back to the configurator, and we're going to basically tell it that on this display number 5, we want to assign the course 1 and the course 2 for the 737. So we go to the layout maps here, which is where we're at. We go to Boeing 737, and we go to the MCP panel, and then we select the course 1, and we'll put it in there, a 7-segment display. and we'll put it on that number 5 on a new entry. We'll click done. And now we're going to put the course 2 on the same one, because remember we're going to use 2 different functions for one display. So click on that, 7 segment display, number 14.5, new entry, and done. Okay, now how are we going to tell it? How are we going to tell it that basically we are going to use that display for 2 different things? We need to assign a way to switch between the 2. But before we do that, we need to tell this encoder that we're going to use for this, that's going to allow us to switch the courses. So we're going to select the encoder, and oh yeah, this is a good point right here. So right now we don't have a uh, input multiplexer for the new one, for the one on the that I use for the right side over there. So we're going to assign that right now. So that input multiplexer is on number 46. So we're going to tell number 46 that we want to add an input multiplexer. And that's it. Now it's assigned. So now we just have to tell it that we want to put an encoder right here on number 46, and the first pin of the number 1 encoder is going to be on pin number 1. So now if you look at it, it's going to show that it's taking up 2 spaces because one encoder uses 2 spaces. All right, so now what's the next thing here? After I do this the first time, I'm going to go a little bit faster, okay? So just so it doesn't take as long as it's already taken. So now we're going to have to use the push button to switch between them, right? But we're going to change both courses. So now we want to also tell it that we're going to use this right here, number 46, and we're going to use the same encoder. So we don't want to replace the one we just put. We want to add it. So we'll put append. So now if we go back to that pin, you can see that it says HSI select course plus 1. And when you click on it, you can see that you have HSI 1 and HSI 2. Okay, so now you want to tell it which selector you're going to use. So we have to assign a selector. So for that, I'm going to go ahead and do all 3 of them now, just because we're going to need 2 of them at least. So we're going to go to the layer, to the table, SimVim functions, and we're going to make selectors. So selector number 1 is going to be a push button that's on the first encoder. So that would be this one right here. I already have the things already because I did it earlier. So I already have all these things written down. That's why I know where they're at. But obviously, if you are going to be doing something like this, you guys should know where you have everything at. Now, selector number 2, we're going to use another push button, and that one is going to be on the second encoder, which the push button is going to be on number 7. And it's going to, I just want 2 positions on it. You can put as many positions as you want, and every time you click that button, it's going to switch over to the next function. So you can technically use one display to show everything on the MCP panel. Each time you click on it, it would switch to the next one and the next one. So let me see. I'm trying to read the comments right now real quick. Sorry about that. All right, so 7 switches, autopilot panel, thrust reversers. Oh my goodness. You have a lot of comments, but anyway, so now you're done. And then the last one is I'm gonna put another selector number 3, push button 46, and this one is gonna be on number, where is it at? Number 11. So that's where I'm gonna put it. 2 positions as well. Okay, so I'm gonna show you guys real quick, kind of the way I do it. I don't know how good it's gonna be on the video camera, but I'm gonna show it to you guys real quick. So this is kind of what I wrote down for myself. I don't even know if it's sharp, but those are all my notes right there for, for all this stuff that I'm doing right now. And I did all this ahead of time because I didn't want to be running through this live as I was here with you guys. So I wrote it all down ahead of time so that I can try to speed it up, but it's not working very well. So anyway, so the only thing we did right now is assign an LED, I'm sorry, a 7-segment display for this number 5, which is a HSI course number 1 and number 2. And then we assigned the encoder to change those courses and a selector to switch between the courses. Now I'm going to show you guys real quick here how that looks. So now every time you make any changes, remember you have to save it, and you have to save it under the name data.config, because the program SimVim cockpit will only read data.config. If you have like this one right here is my main one that I use for my actual cockpit setup, and then I have another one that I had already played around with, but the only one it will read is that one. So yes, I want to replace it. Now, if we go back to the simulator, we have to reload the configuration, and then I will put the camera there, which I just realized that the camera wasn't in the right place, but all right, so I'm going to do that right there, and you can see right now that I will reload the configuration. Oh, wow. Right now it's showing the course number 2. So you see how on course number 2 on the 737, it shows 228, and over here it shows 228. So if I switch it, oh, it's on the wrong one right now. Okay. Oh, I forgot to do one thing. I completely forgot to add the second. Let me see. No, I did. HSI course number 2. Oh, I didn't switch a selector? Okay, let's try that. Maybe I forgot to put that. You see, even though I've done this so many times, I still go through this. So also for the displays, you need to tell it that you want to switch between these two items that are on the same one. So you need to choose a selector for that one as well. So you select selector number 1, confirm, save the file again, overwrite the old one, and then come and reload the configuration. All right, so now let me show you the camera here at the same time. So you can see that I show 152 here and 152 here in the simulator. And when I move it, it moves that course. And then if I push the button, it switches to course number 2, which is 229 in the simulator, and then I can switch it. So I can go back and forth between, both of them and switch each one of them with a push of a button. All right. So right now we'll leave it on number 1. So that's it for that. 229. Yeah, I know it was something that I forgot to do, but it works. I just had forgot something. Okay, so now we're gonna do the same thing. We're gonna configure we're gonna configure the screen number 2. Let me get rid of that camera real quick. We're gonna configure screen number 2 for the heading. Okay, so we're gonna go to the layout maps, 737, MCP panel, heading, 7-segment display, and we're gonna tell it that we want it on this one here. That's number 10, and done. Okay, so that's it for that. Now, we want to also tell it which one we're going to use to switch the heading, right? So we need to select the heading set, and it's an encoder. So we're going to go to our input multiplexer number 46, and that one is going to be on number 4 and 5. No, 5 and 6. That's where I have it. So that's it. And now we want to tell it as well. Oh no, that one we're only going to use for one function. So we'll just go ahead and save it. Now you can see why it's going to be a lot better that I cut this video down, huh? It's going to be extremely long. All right, so reload the configuration here. So now we should have the heading on the middle one, the one on the right. Let me put the camcorder here. So you can see it's 154 here, and it's 154 here in the autopilot here. And when I move it, it changes it magically. So that's doing its job too. All right. Oh yeah, good luck, Piggo. Too bad I can't go in there and fly with you. All right, so that one's working good. Have I lost anybody yet? It's a lot of information, I know. All right, so now we're going to do, that's why I like doing this full screen because it's better. Now we're going to do the third display. So the third display, which is on number 15 on that output multiplexer, we are going to put the altitude and we're going to put the vertical speed. So if you guys, I'm not sure if you guys know this, but the ones that are blue are lights or displays. The ones that are yellow are buttons or switches or encoders. So that's how you can tell if you're clicking on this, that's the light when it's on, and if you're clicking on this, that's the button that you would hit. So we want the screen, which is altitude, 7-segment display, 14, and that's number 15. And we're gonna put it in there. Done. And now we want to tell it which encoder we want to use. Well, actually, before we do that, let's do the vertical speed. So we're going to put the vertical speed as well on output multiplexer number 14, pin 15. Done. Okay. Now we need to have something to switch them, right? So for the altitude is this one right here. We need to select the encoder that's going to be on input multiplexer number 46, and it's going to be on number 8 and 9, sorry, 9 and 10. So that's already assigned. And then the vertical speed, also the wheel, we're going to put that one on the same multiplexer, which is a 9 and 10, and we're going to add it to it. We're not going to replace it. So now we need to tell it that this one here that has two different functions, we're going to use selector number 3 to switch between them. So we'll put selector number 3, confirm, and the same thing for the display, because when we switch to control the vertical speed, we want the display to show us what is going to change, right? So we'll choose selector 3, confirm, and save it again. Well, once again, it's an alarm, it's not a phone call. Okay, so we'll save it once again, and I do want to replace. Okay, once again, let me take you over to the dual screen here. And we're going to, now we're looking at the heading. We got to refresh the configuration. So we're looking at the, I'm not even sure. Okay, this is the vertical speed. That's so funny that it's not even showing anything right there in the airplane. But if we push the button, it's the altitude. So you can see that the altitude is 15,400, just like it is right there. And then I can move it up and down. Now, if you guys didn't know, also another thing about encoders is that if you go to the plugins, SimVim cockpit, input options, you can change the speed of the encoder. So if you move this right here, hold on, the window showed up in the wrong place. So when you move whatever encoder or anything you move last will show up right here. And this shows you what type of encoder it is, or if you have two buttons for up and down. And then this is the acceleration. So if you don't have no acceleration, for example, and I move the altitude, it didn't save it, not that one. Okay, so now you can see that it doesn't move very fast. You see, even if I move it fast, it only moves a couple 100 feet at a time. But if I do acceleration, now if I move it, I can go thousands of feet in very little time. You see that? So this is where you can select how much acceleration you want for your encoders. Okay, so now we are going to program, let me switch over to the full screen camera view. So now we are going to program the auto throttle toggle switch and this light, which should turn on when we arm the auto throttle. And we're going to use this button to arm the autopilot command A. and this one to clear the alert when you disconnect the autopilot. And we're going to use this little light, this little blue light, blue one, number 3, when the autopilot is on, and this one when the warning is blaring off. Okay, so I'll take you out of this view and go back to the configurator. Any questions up until now? Okay, so first, I think I already have the lights programmed right here. I did. You see I have autopilot command on and autopilot disconnected. This one right here I actually wanted to delete. But so I already have those, but just just so you can see how it is basically when you want this little light to show that the autopilot is on, that's the one you would put right here on, because I have that one on number 3, on pin number 3, the little blue light, and then the other one is on pin number 4, and the green one that I'm using for the auto throttle armed is on number 5. So that would be this little light right here on the top. So I forgot to erase them earlier, so I'll just leave them on just to make it a little bit faster now. Okay, so we're gonna do that toggle switch then. So that toggle switch is on number 4 right there. So basically what I'm gonna do is auto throttle arm, go to input number 46, number 4, and it's already assigned. And then the push buttons are number 8 and number 12. So I'm gonna do number 8 when the autopilot is engaged. So 46, 8. And then I'm gonna do the warning, which is this one right here, this autopilot disconnected alert. I'm gonna put that one. Oh no, I'm sorry, that's the alert. I want to do the reset. So I would do the yellow one here to clear the warning. That one would be on number 12 and save. Yes, I want to replace it. So now you can see if you look at the configuration file now, if we take a look at it, oh, it always goes over there. You can see that there's a lot more things on it. There wasn't that many before, but now it added basically everything we added to number 14 here, and I think everything we added to number 46 up here as well. So all of these are new ones that we just added right now. So okay, so now we have to reload the configuration again here. And so let me put the camera back on here. Okay, so you can see yeah, you can see it. Hold on, let me just try to zoom in a little bit more. Okay, so you'll be able to see right there when I turn on the autopilot, and then you should see on the camera, you should see that blue light turns on. So here it goes. There it is. So the blue light turned on. I'm not sure why it's giving me the autopilot warning right now, but it shouldn't because the autopilot is not on. Let me see. Oops, I'm trying to click over there on that. So now when I disconnect the autopilot, now that other light is going off, which is the red one that you're seeing here inside the airplane. And now when I push this button, which we programmed it to clear that alarm, that light should turn off and the warning should stop. So everything's working good. Oh, the auto throttle. That's the only thing we didn't test yet. So here's the auto throttle. When it's on, you can see that in the Zebo, the light came on and my green light came on. And then I can turn it off. All right, one more thing I wanted to show you guys is this is pretty cool. I'm not sure if any of you guys have used, let me get rid of the camera here. If anybody of you guys have used the lighting panels on here, so basically you can set a potentiometer to change the brightness of the displays. So if you go to the layout maps, you go to lights, and you see these up here, you can use a potentiometer to control displays, how bright they are. So for example, I already had selected brightness 1 right here. So now when I go to my 7-segment displays, I can tell them that I want to use that brightness 1 to change the brightness of the display. So I can just do that. And I think it usually does it for all of them, but let me see. Oops, hold on. Let me do this again. Uh-oh. Yeah, no, you just have to do it once. So now for basically for all of them, it'll say brightness not 1. So if I move my potentiometer, let me put the camera view back on here. So I have this potentiometer set to brightness knob number 1. Okay, all the common functions, they work on every airplane. So if I have, like, for example, there's a few of them that are a little bit different on some airplanes. But let's say, for example, I have the knob to turn the heading. It'll work here in the Zeebo. It'll work in the Cessna 172, and it'll work on other airplanes as well because they use regular commands. If you've seen some of my videos where, you know, like you see some of them use custom data refs or custom commands, those will not work right out of the box. So if you have one of those airplanes, like I use the Airfoil Lab Cessna 172, and that one uses a lot of custom data refs and commands. So a lot of the things that work for the normal Cessna 172 will not work for that one. But everything that works by default on the laminar research airplanes will work. So this cockpit that I have right here, which, well, you guys have seen pictures of it a lot of times, but just in case you haven't, let's just say you want to see that. So all of these buttons and switches and everything that I made that are basically standard, they'll work on every airplane, you know, that I use. There's very few that won't work unless they're custom or whatever. But yeah, so that's it. So now let me go ahead and put the, I thought I was going to show you guys something on the camera, but oh yeah, I was going to see why that thing didn't work. Let me see. Why in the world didn't it work? The brightness display, I was trying to see. Brightness control. Yeah, I'm not seeing why it wouldn't work. It was working fine yesterday when I was playing with it. Now that I'm trying to show you guys, now it decided it didn't want to work. There's always something, isn't there? Oh, there it is. But now it's working only for one of them. So let me see. I'll show you guys right now. Let me just yeah, okay. I never understand why sometimes things don't work, but let me put the camera, the outside camera once again. So if you see this display right here is really dim and this one is really bright. And even though all three of them should be changing with that one brightness knob, for some reason it's not. So when I switch this, you see that I can increase the brightness of it and reduce it. So if you don't like them that, you know, strong, you can use something like that to change the brightness. I'm not sure why. Yesterday, this one wasn't working at all with it. And today, this one is not working with it as well, even though all of them should be working. But go figure, maybe tomorrow all of them will work again. Oh, the only thing we didn't do also is I think we didn't change between the vertical speed and the altitude here. So when when I push this button, we can change the vertical speed. The only thing I'm not understanding is why on the Zeebo is not showing up, which is kind of interesting. But yeah, if you look on the Zeebo, I wonder if it's because I have this autopilot reset light on. But if you look on the Zeebo, um, when I move the altitude and vertical speed, it's not showing up on the Z board, and it usually does. But anyways, you can see that I'm switching between vertical speed and altitude right here. So that's all that matters. All right. So I guess that's all I have to show you guys, unless somebody has questions that I have not answered already. You can't wait to see the Bravo. Yeah, it's gonna probably I gotta figure out because I gotta take out my SATIC. So basically, if I switch over to that view right there, so I would have to take out my SATIC right here, and I would need to take out this. I don't even know what I'm gonna do. I might not even use it. I might just save it and hold on to it because I would need to take off my parking brake light. I have to take this off, which I have a lot of my views. I have them set up to that. So, just with this, I can go to all kinds of different views, and I don't really want to get rid of it. So anyway, I would need to get rid of that. The trim wheel here, which, I know the Bravo comes with a trim wheel, and the throttle quadrant, which I definitely want to get rid of because I really like the way the Bravo is going to have the dual and all that. But I do like this trim wheel, and I do love this, my parking brake and everything. So yeah, the parking brake right there, if I go to my, watch, if I go to that view right there, which I just put it right there. So, oh no, I don't have it attached right now, so you won't be able to see that because it's on my other configuration. But yeah, when I pull this parking brake, it actually turns on this light right here that you can barely see. And it also, of course, this light in the Zebo turns on. So it's kind of cool. But yeah, I mean, I don't even know how many people are here with us still. It looks like 10. So if anybody has any questions, go ahead and ask. And if not, I think it's going to be time to call it quits because we've been doing this now for I don't even know how long anymore. 2 or 3 hours. It's a lot of information I think that we had to go over and explain, but I really do hope that some of the stuff were clarified, some of the doubts or questions that people had will be answered, even those that haven't seen it yet that will probably see it sometime in the future. But that's it. Other than that, I think this is it for this one, and I'll see you guys on the next one, either live or pre-recorded.